Yeah, we will start.
Okay, sir. Thank you.
Okay, sir.
Yes. So I welcome you all. I welcome the expert Vishal Rathod sir and all the participants who have joined for the fourth day of our FDP AI revolution from machine learning to generative AI. I would like to introduce Dr. Vishal Rathod sir. He is a senior project engineer at Center for Development of Advanced Computing CDAC in Bangalore, India, in the research and development of IoT group. Under an MHRD fellowship, he received his PhD in computer science and engineering from the National Institute of Technology, Karnataka, Surathkal. He also has a bachelor and master's degree in computer science and engineering from Gujarat University. Dr. Rathod has over 7 years of experience in academia and industry, as well as considerable teaching and research experience. He has successfully completed many MITI-funded IoT security research projects, including a comprehensive IoT security ecosystem and sandbox, developing a secure firmware-based solution for embedded boards, creating an IoT security framework for government organizations, and creating an ultrasonic-based smart water meter, GPON battery management system for startup company and other embedded projects. Dr. Rathod is an active member of academic community, having a lifelong member of IET and senior member of IEEE, member of ACM and IET as well. He is also a board member of IIE Society and active member of IETF, core working group, INTC, and various IoT networking groups. His scholarly accomplishments include the publication of research articles in well-known international journals, FGCS, ad hoc networks, etc., conferences, national as well as international, and book chapters in IET, Elsevier, Springer, etc., as well as receipt of the best paper prizes at prestigious conferences for his study. Among Dr. Rathod's pedagogical interests are congestion control, networking, wireless sensor networks, Internet of Things, performance evaluation, testbed construction, and wireless networks. His principal research interests are in congestion control, IoT security, and designing embedded solutions to solve real-world problems. His dedication to research has led him to engage with numerous resource persons both within and outside of India. So with this, I welcome Dr. Vishal Rathod, and I would like to hand over the session to him. Please, sir.
Yeah, so thank you, Banaraman sir, for inviting me to share the knowledge, whatever I have in this. So I would like to thank the institute, right, and ATAL FTP organizing committee also. So as sir mentioned that my expertise in IoT, right, and now people are more focusing on now how to integrate the various technologies into the IoT domain. Hope, am I audible? And my voice is clear to you?
No, sir. Voice is not clear.
Okay, fine.
If it is little bit louder, it's fine.
Okay, so how it is now? Now it is okay?
Yes, sir. Okay, we'll proceed.
Okay, fine. So the thing is that now people are more focusing on integrating the various technologies into the IoT domain. The various technology teams of what? Like people are more focusing on that. Okay, let's include the quantum part into the IoT, whether it is suitable or not. But still, the research is going on, but more focus, right? Because now the every industries, even in the academia also, are moving that about the AI ML part, right? How artificial intelligence or machine learning or deep learning can enhance the performance of the various domains, especially the IoT. Correct. So before going into that how AI or ML or IoT, sorry, ML and DL can enhance the performance of the IoT network, let's focus on some fundamentals because before moving into the IoT AI ML domain, right? On you already from the past 2 days, right? You already having a knowledge about the how AI ML and DL will work on various problems and various solutions, the fundamentals of that, but you learn the fundamental first and then you apply. So before applying the II MLDL into the IoT network, right, it would be good if you can go through the IoT fundamentals. Okay, so first let me switch off my video and then start the presentation. Let me share my screens. Hope it is visible to you. It's visible?
Yes, sir, visible.
Yeah. Okay. So let's start with it's showing a single screen or multiple screen.
Uh,
It's like two or a single screen.
no, it is a single screen, but you present in the presentation mode.
Okay. 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 Wait a minute. Now?
Yes, sir, you can proceed.
Oh, wait a minute. It's not showing to me. How it works. Mhm. Okay. Okay. So let's start with the basic fundamentals of IoT. Okay. Okay. So the thing is that everyone knows that what is IoT. Okay. So IoT is more fundamentals of previous before IoT, right? There is one network comes which is called the wireless sensor network. Okay, and wireless sensor networks are very well known and researchers are using it. But why people are moving into the IoT? Because in 2013 onwards, right, people are moving into the IoT because Trump coined in 2014 and people are saying that yes, IoT would be good if we use it. But what is the problem in the wireless sensor network and people are moving into the IoT? The main thing is that wireless sensor networks are there. If something happened, like suppose for an example that you have deployed the wireless sensor network, right, in your area or in the remote area, and something happened to those nodes, right? And main thing is that you need a constant manpower, right? Someone has to be present there to rectify the problem, to solve the problem, right? And is it possible that while we are moving away from the remote area and if something happened to the network, whether we can modify it or whether we can access it from the anywhere in the else world and like through wireless sensor network, it's not possible, right? So that's why the new technology comes, which is called the IoT, right? Nothing, the fundamental part is the same. Devices are there, right? To the exchange between those two devices. The connectivity is also there. The main part that included inside that is internet. Now these physical objects are internet enabled and they can communicate directly to other node or they can you can a person can directly access the nodes from anywhere around the world. Why? Because of the internet. Now, if the internet then means it doesn't mean that that will be a deploy like a normal network. No. In normal terminology, we call this nodes or physical nodes or IoT devices we call as a constrained devices. Why it is constrained devices? That because these devices are lightweight, right? Lightweight means they have a limited memory and room. You can't run your heavy algorithms, right, on top of that, right? Because they are, these devices are tiny, right? And these devices are battery operated. Okay, battery operated means, now see, if you have a watch or sorry, wall clock in your home, that wall clock is a battery operated. Now after some times the battery will be drained. Correct? Similar way, these IoT devices are battery operated. So battery operated means if you run a high-end complex algorithms on top of these dynamic devices, right, and you deploy those devices in the dense network, that means it consumes more power. Okay, so another constraint is that you can't run complex algorithm on top of that because the power consumption is the main issue. So these devices are having a constraint in terms of power and memory as well as the computation capability. Why? Because these devices have a limited amount of RAM and ROM. If you think about the IoT device which have a, you heard about the STM32, NXP. These are all manufacturers having a MCU manufacturing devices. Now, if you procure these MCUs and we fit into the
Vishal
devices,
sir, excuse me.
yes, yes, sir.
Hello. Ha. Somewhat voice is not clear. So if you can adjust your mic properly.
Wait a minute. Mhm. Now
Yes, little bit.
it's did the problem. Wait a minute. Setting. It's perfectly fine. Audio is perfectly fine. Okay. Let me adjust my device little bit.
Mm-hmm.
Okay. Now it's fine.
Yeah, fine, fine.
Oh,
Okay.
fine. Okay. So if we include this MCUs, right, inside our IoT devices, they have a limited amount of ROM, like memory, 32 KB of RAM, 42 KB of RAM, or 512 KB of RAM. They don't have any RAM in MB. And whatever system we are using it, it's in TB. RAM is in TB, RAM is in GB. Correct? So see the complexity of these devices. So main thing is that these devices are constant, and think about this AI perspective, right? AI perspective means AI algorithms, right? Whether we can run the AI algorithm on top of that or not. That's the question again. Okay. So just keep this question in your mind. So later, after finishing this introduction part, we can move on to that. So whether we can able to run it or not, that's the question. Now, the thing is that main issue is that they can generate because devices are deployed. After devices are deployed and in a resource constrained environment, right? And in a dense area. So it's not single device. It's a multiple devices. If you think about the network, right, in your city, if you have a uh, in your college, right, if you have a temperature sensors and pressure sensor, right, they have a they have a multiple temperature and the pressure sensors means lots of data is generated, right? And if lots of data is there, then there are various issues comes into the picture. So how, what are the issues, how AI can help to resolve these issues, that we will look into it. Now, if you see the connectivity, right? So these are the applications, right? The chemical IoT sensors, actuators, all are the applications of this IoT. But the main fundamentals part is that,
Sir, Vishal sir,
yeah,
still we are experiencing some echo at the background.
oh, background. No? Wait a minute.
So can you talk directly without your headphone? I think to your laptop, mic is directly available.
Just give me 2 minutes.
Yeah, yeah, no issue. And present your PPT in the presentation mode so that it will be bigger.
So now it works. Hello, Manaraman sir?
Yes, sir.
Or still it is showing the two screens, like next slide or something?
No, it is one screen only, but you are in the presentation mode.
I'm in the presentation mode only.
But then you have shared the other window. You please share the presentation mode window. I
Okay.
think there may be two different windows. One is presentation mode and
Oh, wait. Okay. Now?
yes, sir. Now it is perfect.
Oh,
Yeah.
fine. Okay. Just wait a minute. Wait. Okay. Now, sir, now echo coming or not? Background?
Still somewhat I'm feeling.
What I am, because I am using this system, right, in my office only. So
Okay. Yes, now you're talking through your
headphone only.
headphone only.
Yeah.
Directly you can talk.
Directly I can talk, but it will echo because the thing is
Uh-huh.
that it will come through the camera.
Okay. Okay.
That's the thing. Let me check again.
Mhm.
Because the thing is that here echo will come little bit. Okay. Now,
Okay.
now it's okay, sir. Or still it is there. Hello.
It's okay. Fine.
Okay, fine. If you miss something in between, just let me know. In between.
Yes.
Okay. So now the architecture part. Okay. So how this, because if we think about this any network, architecture comes into the picture. And for the sake of the information to you, there is no standardized architecture in the IoT till now. Correct. But why there is no standardized architecture in the till now? There is a reason behind that. What is the reason is that if we think about the application perspective, let's take a student perspective. Student is building a simple application, right? So if for simple applications, if we follow the TCP/IP layer architecture or OSI layer architecture, then it may be possible that we can't follow all the layers. They don't require all the layers for simple applications like just reading the temperature value and store it in the database and just show them diagram that how much temperature is there. So for that, no need for each and every layer. But if you think about the complex applications like taking the temperature value, then do the manipulation, do the integrations of the various applications, then do the computation, right? And cloud, you can apply some services, right? These all are, if you include it, that means complex application, you need a specialized architecture for that. So in this slide, what is present here that there is an architecture from 3 layer to the 5 layer, right? So once it's evolved with the 3 layer architecture, so see here in 3 layer, one is a perception layer. That means only sensors and actuators are part of that. Next, the network layer. So now network layer means we can set up the network that how can device can send the data to the particular node and it will reach to the application, right? And at application layer, we are simply running the application. So if any simple application is there, then these 3 layers are enough. But once time evolves, right, from 2013 onwards, they started with simple architecture. It's fine. But if right now, if you think about the IoT application, right, it doesn't fit into the 3 layer architecture. What you need is you need a 5 layer architecture, correct? So what is the 5 layers are there? Objects. Object means nothing but the perception layer. Means here in object layer we can put sensors and actuators. That's all. Correct. Now the object abstraction layer come into the picture. What is the object abstraction layer here is simply getting the data from the sensors and actuators and passing to the particular service. That's all. Right. And what is service management is doing here? Now, if you think about the application, several application is running. Suppose in single application, there are multiple services. Multiple applications, there are multiple services. Now, which data is mapping to which services or which application, that part is handled by the service management. So service management here is handling the data, just assigning the data from uh, assigning the value, whatever value you are getting from the objects, the application. That's all. Now, what they include here, see in those two layers, these three layers, these five layers, and these five layers. There is no only application layer is a top layer, correct? But here they include the business layer because in IoT means everything should be in a representation way. Now think about the complex application, and you have a as a in previous slide I already mentioned that IoT network generates a large amount of data. Large amount of data means how to showcase those data. Correct? How to showcase those data. You cannot showcase those data in a raw format, right? Like in MLDL, right? If you have a 3 GB, 10 GB of database and 3000 rows and something columns, 15, 20 columns and attributes are there, right? Are you able to show in a Excel format and CSV format those data, whether your client understand? No. What you apply that? You apply the machine learning algorithm, ARM algorithm, DL algorithms and present in such a way that, right, that it should be visible, it should be understandable, it should be interpretable. Correct. Similar way, whatever in IoT is there, we also need this type of thing. So whatever raw data we are getting it, we did something that layer that we can represent those data in front of client or in front of things. So here the business layer come to the picture, and this business layer is nothing but we can apply the visualization techniques. Like you can apply the matplotlib, you can apply the GNU plot and represent the data in such a way that your client or your user can easily interpret. So this is the architecture part. Hope you understand this properly. Anyone have a doubt inside the architecture or any questions? Please ask me. Okay, fine. If you do not have
No,
any, we can take
no
later.
question, sir.
Okay, fine. We can take later on the question. If you have any in between, if you have any doubt, just stop me. Okay. So now everybody is thinking about IoT, but what are the characteristics of IoT? How can we define this characteristic of this IoT devices? First, characteristic is dynamic and self-adapting. Like you are deploying a node. Like think about the wireless sensor network that previously was there. Once you deploy a sensor, are those sensors are once deployed, it automatically starts working? No. In wireless sensor network, it's not possible. Why? Because the thing is, once you deploy it, right, you have to configure this device and then deploy. Then it will start the working again. If without configuration you deploy, that will be a problem. Right? But in IoT, internet is there. Right. So what happened that once you deploy it, right, in the network, a new device, right, first it will configure by itself through internet, so self-configuration, and then something something like suppose this device is sending the data, this device is suppose one device is sending the data to the one node, but that node is now uh, inaccessible or something happened to that node, error comes. So in routing it has to pass the information through another node. So adapting the self-adapting the network automatically. It's not like adapting wireless sensor network. It's not self-adapting. You have to specific code it. If you specific code it, if something happened to that network, that means you again go reconfigure and then work. But here, self-adapting, self-configuring is a characteristic. Node can automatically configure by itself and adapt the network condition dynamically. Now we need interoperable communication protocol. Now what is means interoperable communication protocol means, see, here what we are using this is also required in wireless sensor network also. Right, there's a correct. So what happened that when we deploy sensors, actuators or IoT devices, it's not like that we can procure hundred of devices from one manufacturer and deploy. No, we are not doing like that. We are procuring the devices based on our requirement and that will be from different manufacturers. So if different manufacturers are there, then If we deploy those devices, that means both the devices, those devices have to communicate to each other, right? Even they are from different manufacturers. So interoperability should be achieved. And for that, due to communication, we have a separate interoperable communication protocols, right? Now next is a unique identity. Okay, unique identity is required. Each and every device has, like you have a unique name, device has to be unique identified and integrated into the information network, right? That is just any wireless sensor network or any network have a, this type of characteristic. Now the main thing is that IoT network doesn't work on IPv4. Remember this, IPv6 network. So IoT network works on IPv6 network, doesn't work on IPv4. That is the main thing. Now people are saying that yes, IoT devices are there, IoT devices are there, but what is inside the IoT device? Anyone look into it? No. People are just taking the picture of the IoT device and say, yes, this looks good. Let's start working on it. But what is inside that? If you are doing a hardware design or research inside that, then you should look into the what is inside that. So let's take an example of that. Let's take an example of Raspberry Pi. Right? People are considering as a IoT device. Yes, is it? It is true. It should be IoT device, but it's a high computational IoT device. We can say that. Why? Because it has a vast amount of RAM and ROM, and also we can install the OS inside that. But if you see the STM32 board, correct, ARM board, NXP's board, okay, those boards are not high competition IoT devices, or like they have a limited constraint IoT devices because you can't run complex applications. So both the devices, if you see, some of this part are inside that. So let's take into the one by one, right? First, if you think about Raspberry Pi, we will do the comparison of each and every block in terms of Raspberry Pi and ST. Okay, so see, first the connectivity. In Raspberry Pi, connectivity is there through USB. We are giving the power, right? And also Ethernet is also there. In some of the STM boards, we are giving the power through USB host and Ethernet, right? Both are there. Now processor, CPU is already there inside the Raspberry Pi. If you think about the STM32 and other boards, we have MCU. So processor unit are also there. Audio video, yes, Raspberry Pi has. STM board doesn't have, but they have a uh, what we call the video interface, right? Video code or video, we can say that not card, but we have a video driver inside there. So if we have to connect the video editing device or the monitor inside this, it will easily connect. Now the memory, both the boards have a memory, right? But in type of NAND node or DDR RAMs. Graphics, again, it required based on the application. Storage devices, yes, uh, STM32 NXP boards, those are have a eMMC memory, right? But Raspberry Pi has a SD card, right? They have a slot, separate slot. Now the main part is that how this device can communicate. Now suppose you have a you all of you wear a smartwatch, right? And smartwatch, take an example, smartwatch reading the sensor heartbeat data. Okay. Now if you see the heartbeat data, okay, it will read, but you didn't give it the command, right? And heartbeat data is after sensing the heartbeat data, it will send to your mobile also, right? Now how this work, because sensors are down in the smartwatch, right? It will, sensor is reading it will send the command to someone, right? And then it will send to the mobile. So now sensors and actuator talk to the small black chip. If you see the Raspberry Pi or if you see the Arduino also, they have a black chip which is called the microcontroller, right? So we are attaching the sensor or interfacing the sensors and actuators to this microcontroller, right? So microcontroller is giving the command and to the sensor actuators sense the surrounded value and send it back to the microcontroller. Correct. So now how the sensor actuators will communicate to the microcontroller through these interfaces, communication interfaces or IO interfaces. We can say that UART, asynchronous transmission receiver, serial peripheral interface, SPI, I2C, and CAN. If you think about the mobile automotive area, then the CAN protocol use. So I see, if you see any IoT devices, If you attach any sensor to the Raspberry Pi, any sensor attached to the STM board or Arduino board, right? The communication from sensors to the microcontroller is done through this IO interfaces, either UART, SPI, IOC, and CAN. How can you identify that? You have to go through the data sheet of that microcontroller. Then and then you can identify it. Now, if you think about the broad architecture of IoT architecture, so IoT doesn't mean that only single architectures, like we can deploy sensors in some, we can put one gateway and get the data. No, IoT network consists of various communication architectures or various resource constraint network. If we assume that this is your IoT network full, inside that, sub-IoT networks are there. So what is sub-IoT networks? Which are the sub-IoT networks? Take one this. If you have a surveillance camera in your city, that means all surveillance camera are communicate through Wi-Fi. Okay, this is one IoT network. If you have a health profile, like smart health environment you set up there, right? Then it's again one IoT network. If you set a smart waste management, again there is another IoT network. If you think about the smart water meter, right, distribution, one IoT network. Home energy, home automation, one IoT network, right? These are all IoT networks, right? And the main thing is that if you deploy sensors inside that, then it would be okay. If not, if you put the IoT devices, then you can directly access those devices. But the backbone, if you see the backbone of this, each and every network has some gateway, or we can say as a router, right? And those devices are access to the sender to the router, because if these devices, all these devices are sent here to the here backend, it will be totally chaos here. So what each and every resource concern network, we need a gateway. We need a gateway. We need a gateway, and this gateway are directly communicate to the backend system. Correct. So now the thing is that in the first slide I said that should AI algorithms directly deploy on these tiny devices, or now if we apply these algorithms on this gateway. Correct. These two questions in your, just keep in your mind, right? And once the device sends it to the data gateway and gateway to the backend, in backend we can do anywhere, because here we have the wired network. Mostly here is a wireless network. Don't have wire network here. So either they have Wi-Fi, Bluetooth, or GSM connectivity, or LoRa connectivity, okay, or Zigbee connectivity. So these are the protocols. So here each and every protocol will work wireless environment, but here is the wired network. So now think about that. Where should we apply the AI? That is the main concern. Okay. Now, if we think about the protocols, see here we have a here we each and every layer are there, and each layer supports some of the protocols. Think about the link layer. They have Ethernet, WiMAX, Wi-Fi, LoRaWAN, cellular. Network layer mainly two, IPv4, IPv6. But if you think about the IoT, one other protocol is there, which is basically IoT network called a low power personal area network, right? So IPv6 low PAN, another protocol inside that. Transport layer, everyone knows, mainly two protocols, TCP and UDP. And application layer, there are specialized application layer protocols that are designed for the IoT environment, like CoAP, MQTT, EDS, EMQP. Other protocols are simply that are used in wired network. You can also use in wireless network in IoT network. So see, normally what happens that if you think about the IoT device, it's basically a low power personal area network device. So it follows the 802.15.4 type of communication, right? The radio communication. So see here, I have mentioned the particular. I have in this slide the stack comparison is there. So if you see the stack, right, and each stack which protocols are there, and there's specific reason for that. I will explain that what is the reason for that. So see, IoT devices are tiny, right? So you cannot use. They are using the RF communication or radio communication, and they are 6 low PAN. So mainly they are using 802.15.4 standard. which is a low power personal area network standard, and basically ZigBee, right? MAC layer, duty cycling we leave it just now for the sake of few seconds. MAC layer, everyone knows CSMS CA, right? The carrier has multiple access and collision avoidance, right? NAT scheduling also can happen here also. Now adaptation layer also required. Why? I'm telling you. Network layer, mainly if you think about IoT, IPv6, but some of the protocols like web sockets we use IPv4 also. Routing, specialized protocol is there, which is called the RTL. I'm not going into deep. I'm just giving the name. Each and every protocol. Suppose you do the research on RPL protocol, only PhD and master work you can do. There is a well-known Sunrise RF Sunrise protocol is there. Routing, the routing protocol for low power and personal area network, especially designed for IoT network. Transport, we have a similar TCP UDP, and application is application layer protocol. We're building the applications using this application layer protocols. Now it's come into the picture that once, because we see that if we think about this stack, we can see that the ones at client side we are using the same stack, server side we are using the same stacks, and each and every nodes, if you have multiple nodes, each and every node is following the stack. So once packet is passing from the application layer, it will go to the transport layer and routing happen inside that. Now main come into the picture. Why we need a separate layer which is called the adaptation layer, right? We can remove it and directly pass that, but the main thing is that, see, here in radio environment, radio stack, in radio layer, we are using 802.15.4, right? Which is low power pulsar area network, and it has a maximum packet size is only 127 bytes. Maximum. Okay. Maximum packet size is 127 bytes. Now think about, because IoT network mainly use IPv6, right? Addressing schemes, and the minimum packet sizes of IPv6 once it's come to the top. I'm not talking about top, just minimum IPv6 packet size is 1280. Now see, 1280 plus these two layers, header and footers, right? And here the maximum is 1727. How this packet can fit into this to go outside the network? Correct. We need something here that can, because we are not using TCP here. Mainly IoT protocols use UDP. So the fragmentation, reassembly, and header compression. These three techniques required to fit this packet size into this packet size. Correct. So for that, 6LoWPAN is required. The full form is IPv6. 6 is for IPv6. Low means low power. PAN means personal area network. So IPv6 low power pulsar area network. They separate protocol, right, which used for header compression, fragmentation, and reassembly, and then it can fit into this. Now this keeps also one layer which is called the duty cycle layer. I already mentioned that IoT devices are constrained in terms of power and memory. Now think about the power. Take an example of your mobile, right? You feel experience or not? I did experiment. Charge 100% your mobile and put it aside in the night. Just switch on the Wi-Fi, Bluetooth, and the mobile connectivity. Correct. And see the battery consumption in the morning. Almost 20% reduction is there. Correct. But if you switch off this Wi-Fi, Bluetooth, and mobile data and check morning, right, you will find hardly 3 to 4%. That means if your device is in idle condition, still it consumes the power. Why? Because it's constantly searching for the connectivity. Similarly, in IoT nodes also, right? We need something mechanism that we can consume, uh, we can work, we can we can consume the least power. So what we can do is we need some protocols, right, that can handle this the energy consumption mechanism. Means the constant this device should not be in constant listening mode. It should be listening idle likewise. Once the packet is to send or receive the data, it should be in the listen. It should be on. Take the packet, send the packet, take the packet, and go to the idle mode. Means then it won't consume that much power. That's why duty cycling layer is inside that, and uh, it will consume the less power, and different protocols are there. Now see how we can integrate AI, right, to solve any of the problem. Like take an example of power consumption. how we can solve it, right? How we can solve this routing also using the AI, whether it's possible, right? This type of questions come into the mind, and whether AI will resolve it or not, that we will see. Now this is a normal routing path, intermediate node. Once the packets come to the source, it will go up to the routing layer to the intermediate node, and then to the destination path. So the simple things. Now, three fundamental things you should understand, because you should apply, right, your AI, ML, and DL algorithms on these three fundamental things mainly. One is the communication model, right? Next is the communication pattern, and last one is deployment techniques. Deployment techniques we can't apply, but communication model and communication pattern, you should understand those two things, right? Based on that, even the communication, even the deployment technique also, because in some of the application deployment techniques you can apply the IIML. So now these three fundamental things you should understand, and let's start with the first communication model. So there are basically four communication models. One is a request response communication model. Everyone knows that how request response communication model works, right? If you are familiar with HTTP, so client can send a request to the server. Server is fetching the resources from the backend, right, as per the resource representation, and then prepare the response and send it to you. So normally, HTTP protocol, or for an example, you can say the browser. When you put something URL in the browser, it's basically using the request response communication model. You request something, you will get response. Publish subscribe, right? In publish subscribes is very well-known communication model. Everyone has a YouTube, right? You are watching YouTube. YouTube is following the publish subscribe model, correct? Now, how it works? So someone is published the video, and you are the subscriber or consumer. You subscribe to particular topic now, right? To particular topic. Like suppose I am the publisher. I I am publishing the video on tech channel also. I am publishing the video on gaming also. Some of you are like gaming, some of you are like technical channels, right? So consumers subscribe to particular topic like gaming and tech channel, but who will manage all the things? Broker. So in terms of broker is YouTube, right? So this is a simple example of publish subscribe, push push pull. Famous example is Instagram, right? The publisher publish the things. Here the publish subscribe same model, but instead of here the broker thinks is that means all the data are here in dump. So YouTube is maintaining the data on servers, but here the maintaining the queue. Once queue is full, it will you are pulling the data from the queue, so it will maintain properly, right? And it has an advantage also. Correct. Next is an exclusive pair. It's simply like a TCP connection. First, you have to establish the connection. Once it is done, then you can do the communication, and at the LAN, you close the connection. So these are the four communication models that mainly IoT network use: request response, publish subscribe, push pull, and exclusive pair. I'm not going into detail, but you should understand the overview of that, so you can understand where should we apply AI. Mainly the request response communication model is used the REST-based API. REST means nothing but representation state transfer, and they have a separate architecture principles. Set of rules are there that you follow. WebSocket based the communication is right. Now deployment techniques. So mainly deployment techniques are several deployment techniques are there, 1 to 6, but I will give you a brief overview that because we have to focus on AIML part. So that totally divided into two parts. Either you can do all the deployments at the local side, right? Or either you can do all the deployments at the cloud side, or both. Some of them are local, some of them are cloud. Based on that, the deployment level is decided. You can see that level 1. Level 1 means all the things are at the local side, means your level. You can say, deploy the sensors or monitoring node there only, do the computation analysis at there only, right? Maintain the database also at local only, application as the local in local system that will send the data, access the database at local. So all things are local. But you see here in level 2, right? Cloud storage are there. So database and application are running on the cloud side. Only the monitoring device, node, as well as the resources and controller service are in the local side. So based on this, level 3, level 4, level 5, level 6, this different, right, deployment techniques can work. Now see here, cloud is integrated into that. Now think, if cloud is integrated, that means how much data is there. And if data is there, then definitely you should think about the AI. That's the fundamental things. Correct. So this is deployment techniques. Now next, the communication patterns. This is RFC 725 standardized. So basically there are 4 communication patterns: telemetry, inquiries, commands, and notification. Whether you think the communication between 2 devices, device to gateway, gateway to device, device to cloud, gateway to cloud. If you think all this communication scenario, it resides in these 4 communication patterns. So telemetry and notification are unidirectional. Telemetry means if you deploy the device, device sends the surrounding information and send it to the systems. That means telemetry. Notification means if system have some change in the configuration, right? System is having change in their configuration, it will send the notification to the device that system is changing. So now you can send the data according to that. Now inquiry and command, right? These two are very well known. Inquiry and command means, think about the normal scenario that you are facing here. Okay, uh, like you are going by bus, right? And you're going to the bus station. Now, if you visit the bus station, bus is not, you put in the inquiry, right? So you put in the inquiry, you ask some questions that when the bus will come, and you will get the response from that, right? So this is a normal inquiry. You are doing the inquiry, the response should come. Similarly, when here in IoT environment, device will make an inquiry to the system that say there is any change in the system, there is any requirement to specific parameters should be updated. Either I am sending periodically, whether you need a something change in the transmission, all the things it will inquire, and then response, system has to respond, yes or no. Commands, like professors giving command to the students, like give me the assignment on this day, right? Means straightforward command you have to follow. Similarly, way devices also here the system is also giving the command that yes, instead of suppose now device is sending the data to periodically, is send it no, I want in particular 10 seconds, not periodically 5 seconds or continuously. System is giving the command, device has to follow. Right. So this is the communication patterns. So communication model, communication pattern, and deployment techniques. Now we move on to the application layer protocol. I am not going into the deep. So see, normally if you think about the IoT, correct? If you think about the IoT environment, right, and IoT devices, right, normal protocols can't work. Like HTTP. Let's take an example of same example that all of you wear the smartwatch. Correct. Smartwatch you are wearing, so sensors are inside that. Right? And if you think about the heartbeat data is sensed by the smartwatch, and this heartbeat data is sent to your doctor, right? Because you have assume that you have a BP problem or your heart is pumping so fast, heartbeat is fast. So what you are doing is this device, your smartwatch, is sending the data to the doctor. Right? Now sending the data to the doctor, they use some HTTP protocol or something, traditional protocols. What happened that? Why traditional layer protocol can't work? I'm giving an example of that. Because see, heartbeat data is only 2 bits, maximum 3 bits data. And if you use the traditional protocols, they're mainly using the TCP, right? So what happened that if you use TCP, the fundamental things of TCP is you open the connection, send the data, and close the connection if you are not sending. And mostly the IoT devices are sending the data periodically or event based. When event is generated, then you can sending the data. Otherwise, you won't. If this type of communication is there, and if you use the traditional protocols, right, it may be possible that by sending the data similar small amount of small bits of data, it creates the overhead in the network. So no, they IETF community, the Internet Engineering Task Force, the research community is there. They come up with a new lightweight protocols, right? So instead of HTTP, you can use CoAP, right? Why CoAP? Because if you see the IoT network, which is low power and lossy network, right? Devices are constrained, network is also constrained, and TCP's connection is there. That means every time open the connection to sending the small bits of data, it becomes heavy. So we need a lightweight protocols, right? And yes, web is a lightweight, specifically designed for IoT network, right? And it is standardized by the IETF, right? And main thing is that it runs top of 2 UDP. It's run on top of UDP. Still now the research is going on, right? How CoAP works on TCP, but it runs on top of UDP. And similar functionality like HTTP, but minimalistic header, right? Minimalistic header as well as the complexity. So even the CoAP protocol achieves the reliability to confirmable. So I'm not going into the deep because we have to more focus on this AI/ML part. Another protocol is that MQTT, like which works on publish subscribe. CoAP works on request response. MQTT works on publish subscribe. So mainly thing is that MQTT is a lightweight again protocol, but it works on TCP. Correct. So the persistent TCP session is maintained and then communication is happened. Now let's move on to the main agenda. So now you have a fundamental things, understood the fundamental things of IoT properly, architecture part, what is how IoT works, right? Then communication model, how the device should looks like, what are the component in the device, communication model, communication pattern, deployment technique, and some of the application protocol. Now, why AI should be part of that, right? For IoT, because see now people are focusing on AI or ML or DL, and now previously people are working on it. Now they are saying that it has a good power, it has a good ability. Whether we should integrate into something new technology and come up with these things. So they come up with they integrate artificial intelligence into IoT, and mainly people are pronouncing into two way. Either they pronounce AI IoT, or the short form is AIoT, which is artificial intelligence IoT. Now, everyone knows about that. What is the main feature of IoT? Can anyone in the audience can tell me that, because previous 2 days, right? You also already go through the AI part. So, what is the main of or main objective of AI? Anyone from the audience?
To mimic like humans, sir.
Yeah, to mimic like humans. Correct. So we we integrate the intelligent, right? Integrate the intelligent part into the machines. We integrate the intelligent part into the machines, and that machines can work and learn something like humans can do, right? But why we do it? Because we want to remove the human intervention, right? Because sometimes what happens that human intervention is required in some of the applications. It's not like that we can totally remove it, but in some of the applications it's not required. So we can integrate this AI, we can integrate the intelligent into the machine, and that machine can work like or learn like or can think like humans, right? To remove the human intervention. Now, what we can do is either we can use by develop algorithms, we can run several models on the machines, right, to perform the task or something. Correct. Now the main thing is that, right, how this why we need to integrate the AI into the IoT. That is the main reason, right? So see here, they have a this combination AI plus IoT combination. It works very good, right? Works very good. There is a reason behind that. Why it works very good? Because the thing is that what AI needs. Anyone can tell what AI needs. So uh, we can say like that. Yes, it is good, or it's follow the ethics, or it's follow the some impact on that by while integrating the AI. Like suppose, let's take an example that so you can understand that. Like in daily life, Suppose in your room or in your cabin, you have a AC and temperature sensors, and single temperature sensors, single AC. Right? Hardly they are communicating to each other in day, and if they are hardly communicating uh, in a day, that means how much data should be there. That is very important, right? Because if you think about IoT, all things people are thinking about the data. That's all. Am I correct? If data is there, then IoT can, oh sorry, AI can work efficiently. Am I correct or not? Now suppose, let's take an example of that again, so you can understand properly. Right? Suppose you have a hardly 50 rows of data, 50 rows, two or three attributes, and one is having a 10,000 rows, 20 attributes like this. If you run AI on both of this, right, which one gives you more accurate results? Can anybody tell me? Anybody from our audience? You have a 50 rows, one having a two, three attributes to 50 rows, and one having a 50, 20 attributes with 10,000 rows. On which data set AI algorithms works efficiently? Anybody from audience?
10,000.
Why?
On the large data set, sir.
What?
As much enough data we have, the AI will work efficiently.
Correct. Correct. As much data you have, AI can work efficiently. Correct. Now, come back to IoT again. All of you are aware about the IoT and how much data it generates, correct? Yes or no? Right? If you think about the large IoT network, right, the most challenging part in IoT is that you have a sheer volume of data, correct? Large data, correct? And now think about the integrating AI to the IoT. If you have a data, how it can help, right? Definitely, this combination is deadly. Correct? This combination is deadly. You have a data, you can't go for a data in IoT. Normally, you have to search the database. Correct? You have to search the database when you have to work on AI, ML, DL. Yes, this much database is there, and mainly, if you are presenting something, first question is that how much large data set is there, how much rows are there, how much columns are there, how much attributes are there, and you present the algorithms or your efficiently, and you achieve this much accuracy, right? But if see the IoT data, and if you run AI on top of that, right, definitely you will transforming this industries, right? To the and giving the operations, helping the operation, enhancing the user experience, anything you can achieve, right? And see the market of that. Correct. If you see the global AI market by technology 23%, right, in percentage format, 55% is handled by the machine learning part, and remaining are from NLP. See the AI part. And see here from 2023, the evolution up to 2020 from the last up to 10 years, right? So global AI market in platform side is also increasing, software side is also increasing, even the service side is also. All three layers, right? All three areas are need to integrate the AI, correct? And see the CAGR report, it 36.7% increasing in the IoT. Mainly, people are using it, offering it, right? And several market are there, and even now the key players like Qualcomm, right? I'm talking about the chip manufacturing, correct? Because AI can integrate onto the system on chip also. It's not like on the IoT, but system on a chip level also. Correct. So IBM, Qualcomm, STM, ARM, and XP, all are having a separate unit of AI. right? That can work on that because they are in the hardware, they are in the software. They have to analyze the data. They have to come up with that. Then and there, the both hardware and software can match it and they can sell it. So it is good, right? And market is also saying that it's a good market conditions. Now, what is the challenge of the data in IoT? First, volume. IoT generates vast amount of data, right? So much data is there, so you don't think about the volume. Volume is a challenge in IoT, right? But it's an advantage in AI, right? Data volume challenge in IoT because how to handle this data, how to store this data, that's a challenge. If you want to represent this data, again a challenge. We need visualization technique. So, for AI, it's advantage. Velocity, right? Data needs to be processed at real time, right? That's again problem. We are storing the data, so processing is also problem. And variety of data. So think about that. IoT have a variety of data. It's not like only temperature data. If you think about the smart city applications, you have a various amount of data in your side at your side, right? And from the diverse or heterogeneous sources. It's not. And if you data is coming from heterogeneous sources, all having a different formats. See, so manipulating, accessing, right, and the processing of data is again a problem in IoT. But whether AI can help it inside them, that we have to think. Now, what is the need of AI in IoT? First, the complexity. So data is so much there, you can apply the AI algorithms inside that, do the proper analysis, and it will help the industry, right, to take the decisions, right? So automated decision makings, right? We can optimize the performance. We can remove the reducing the human intervention. Like uh, previously, let's take an example of in Surat, the diamond cutting factory is there. Previously, what happened that people are using, so human are there to cut the diamond. But now, by technology comes into the picture, several diamond companies are using IoT part and automate the part, right? We give the inputs, right? They use the SCADA technique, they use the PLC, but the automation through they are doing. So automating things, right? And even the decision has to be done by through IoT only. The mobile can operate the SCADA PLC system. If mobile operates through internet and they have a sensors device inside that, that means decisions AI should be integrated with that. So once give the input like the diamond should be cut in this way, it automatically cuts. Right? Sensor will automatically sense, cut it properly. This way, so automatic decision we can get the real time inside of the data, right? So if we have some uh, integrate the suppose sensors are deployed in some factories, chemical factories, and we apply the AI algorithm inside that, right? So we can prevent the disasters, right, by getting the real time analysis of the data. So there is a need of AI in IoT by using these three things. And four stages of IoT maturity are there, and each and every layer you can apply AI. While monitoring also you can apply AI to control environment. For the controlling also you can apply AI. For the optimization purpose you can apply the AI, correct? And for the autonomous vehicle also, like think about the Tesla car, self-driving car in US. How it is self-drive? They have a sensors, they have a cameras, right? So what they are doing is camera can sense it of objects. They apply the AI onto that, right? And based on that, they will take decisions, and then it's whether it should take properly aligned in the same lane or whether it should be parked properly or not. All this you can achieve it by integrating the AI. So if think about the techniques, AI techniques in IoT, you can use the machine learning, right? You can apply the machine learning algorithms, you can analyze the data, identify the patterns, trends, and anomalies. You can apply the deep learning inside that. So, what deep learning can help inside that is deep learning model like ML plus neural networks, correct? Uh, ML plus neural network, you can use the image recognitions, right? NLP you can add to predictive maintenance part. So deep learning algorithms, because it will you can apply the neural network and the predictive maintenance, right? All the things you can apply. You can get the benefit of that. Computer vision, right? The computer vision is technique like we have a surveillance camera systems, right? So you can apply the image visions like in every city in Bangalore, right? Even in your Maharashtra, everyone having this CCTV camera. So through video analyzing, through image analyzing, you can identify all the things. Even the drones are also part of that. You can apply the AI algorithm on drone to get the uh, efficient prediction on the disease or whether the soil is become a dry in few hours or not. All the prediction you can do it, right, in autonomous vehicle. And last one is the NLP, the natural language processing technique you can use to text data, to analyze the text data or to pretend something, to take the input from the text data or voice or chatbots, right? So if you see the Siri, right, Siri or Google Alexa or Google, uh, the part is that all are using the NLP inside that because they have a automation in simple way, right? From text they have to analyze. You speak something, they will search the database and get back to you the results, right? So the simple chatbots and all the voice assistants are using NLP. One of the other technique we can use the reinforcement learning, right? Federated learning, right? If you see the research area inside that, there are vast amount of research. You can apply the federated and reinforcement learning in the IoT, right? And you make the decision based on the feedback, right? Make the decision based on the feedback that they are given. So the lots of techniques are there. So if you use the machine learning technique, data analysis part, predictive modeling, anomaly detection, also you can use like the security. The security is the biggest concern, right, in IoT. So anomaly detection or attack detection, you can definitely do by using the machine learning algorithms if you have a database, right? So your network is prone to error or not. Several deep learning uh, used like for advanced analytics, image and speech recognition systems for IoT devices, right? Facial recognition also you can use for that. The predictive maintenance, right? Using the deep learning and personalized experience, you can use the computer vision techniques like identify the CCTV camera, surveillance camera, right? NLP, chatbots, sentiment analysis, voice control. Now the main thing is that edge computing, right? People are thinking about applying the AI through in IoT, but now thinking about at edge computing also. Why? Because see, devices are sending the data, right? You can't do computation at the device level. Either you do the computation at the gateway or some edge node, right? And then you send to the cloud. So now the thing is that people are mostly thinking about applying the AI at the gateway only, but at the edge node also you can do the computing. Why? To reduce the latency, improve the efficiency, because latency should be reduced inside there, and privacy also you can achieve. Right? My previous questions was that I told that to keep in mind that whether AI can help in energy consumption. Yes. Now see the pattern of communication, right? See the pattern of communication, how the frequently communication done. You can apply the algorithms, MLDL algorithms, and find out that at some particular time, at what time the device is sending the more data, right? And then after you can work on that and improve the energy consumptions. Okay. Even the radio environment also you can do. Now, what are the things that you can improve it, right? So these are the benefits that you can get by applying the AI into the IoT networks. Like improve the data collection and analysis. So you can get the real-time insights. Once you get the real-time insights, right, you can apply the algorithms. Then you can do the predictive maintenance. You can enhance the accuracy part of this, right? Right, and you can take the decision based on whatever data you are given, right? So optimization, organization, like personalize whatever we did the computation, based on that we can make the decisions. Now we can mainly in IoT network or industrial IoT, the AI can be used for this purpose: predictive maintenance and optimizations. Think about the chemical factory or something about the Bhopal, right? Everyone knows about the gas leakage, right? So if predictive maintenance is done before that the actual disaster occur, right? Can save the life of a lot of people, right? So what happened there? How AI can apply? Now suppose sensors are deployed there, right, in chemical factory, and those sensors are sending real-time insights data in there. Right? You can take this data, real-time data, do the federated learning and reinforcement learning, take the feedback like constantly hitting is there, right? Sensors is hitting or something, or that is too much the cost uh, crack is there inside your chimney or something, right? And based on that, you can take the decision and send the notification something like feedback based that maintenance is required at particular interval, at what interval, or send the notification that yes, now maintenance is required, right? And by using these techniques, you can reduce the downtime of the particular system as well as the cost. Because if you do the maintenance, like take an example of your bike, if you do the servicing of bike after 1 year, and if you do the servicing quarterly or half yearly, right, you reduce the cost. Definitely, you reduce the cost, right? Because if you do the yearly service, some parts are definitely damaged. You have to change. But if you do half yearly, you can reduce the cost. You can't change. Just clean it and work. Correct. So this way, the AI can be a part of this IoT, and definitely many industries are moving towards integrating AI into IoT, especially in industry IoT for the predictive maintenance and optimization. Similarly, customer experience is already enhanced if you get the supports, right, proactive supports, or based on your recommendation it will work, right? Then definitely customer experience is enhanced, right? Like chatbot, anytime since we can ask them, they can send us, right? So see the AI can, uh, right? The revolutionary AI stream supply chain operation, that is very good. Why? Because streamline the supply chain operation in IoT or industrial IoT is very good. We can get the visibility, predictive analysis. We can automate the process, right? Streamline, automate the process like Amazon. Everyone visited the. If you see the video of Amazon, right, in US or UK, I don't know. Just a minute. In US and UK, they don't have a like in our DMart or something in store. They have a manpower, correct? But in Amazon store in US or UK, I don't know the exact location, but they don't have manpower. So directly people scan the QR, go into the inside the Amazon store, procure something for the products, any product you can purchase, right? While coming out, right, it automatically bill, detect the amount from your that. You don't have to wait for the long queue to do the billing and all the things. How is it possible? It's a streamlined supply chain operation. Even in the uh, what we call that to supplying the logistics, right? You can use this AI part. It can easily, like suppose in one store, if you put the AI algorithm inside that sensors is there. Now, suppose few packets are like take an example of chips, Lay's chips. They use Lay's chips packets are less, right? Only 2 3 packets are left. Immediately notification sent to the AI algorithm compute that, send the notifications to the vendor, right, who is supplying it. It will immediately get notification. They will supply before you place the order. Correct. So that you can do. The AI can be streamlined the supply chain operations. Definitely, this has the warehouse management also you can do. But the main problem is that it reduces the human errors and delay, but it's still challenging. People are implementing, challenges are there because security comes into the picture, right? Similarly, mitigating risk and improving safety also you can enhance the security, right? Emergency response system, healthcare. Think about the healthcare domain. Okay, if you think about the healthcare domain, you can easily understand that how it's required inside that. Okay, so healthcare device like you can use the AI algorithms, right, to trigger the something emergency situations, to analyze the data, like analyze the heartbeat data, analyze the pacemaker data, right, and based on that you can analyze and send a notification to this particular response teams, or you can personalize the health insights, right? Based on the data, you can give the recommendation of the food, that what type of food you can consume or what type of food you don't have to consume. Next is the driving deficiencies in the smart cities, efficiency in the smart cities. Like the smart city means they have a healthcare also, they have a smart home assistant also, they have a automation autonomous vehicle also, right? They have a intelligent security cameras, right? All the things are there. Now AI can definitely help inside that, like traffic management. It can reduce the congestion, right? And give the notification to the commuters that yes, this way traffic is there, you can take the other route, right? Optimization of the resources like waste management, right? How to dispose it frequently or not, take the waste from the efficient way, right? And improvement in the citizens, like engagement, interactive session with this the citizen, and we can take the information, right, and take this like federated learning, take the feedback and then improve the systems. So smart city can efficiently we can improve, right? IoT and AI healthcare I already covered. Agriculture, right? This is one of the area, right, that is definitely AI can help. Okay, now if we analyze the soil data or weather patterns or crop prediction or optimizing the planting and harvesting process. So from sensors we are getting the real-time insights. What we can do is integrate the AI algorithms inside that, either MLDL or anything, and we can give the recommendation to the farmer, right? What type of things you can do, what type of crop you can raise, right? So this way AI can definitely help, and this is a research problem. Whatever I am talking here, like integrating AI into IoT, whatever the examples, what are the problems I am giving, right? This is a totally research problems. Either you can go with the AI part, either you go with the uh, master's thesis or PhD thesis, right? This is definitely helpful. Manufacturing industry, I already told, right? So if smart factories are there, if you include the AI into that, if you leveraging the AI features, right, you can improve the quality control, right? You can drive the innovation part inside that. You can include several new features in your factory. You can do the proper maintenance, so downtime can be reduced, right? So all the things, the productivity definitely improve. So all the things can enhance in that, right? Security and privacy also concerns in databases are there, privacy violations. All the things are there, and ethical consideration for IoT and AI integrations is three parts: data privacy, algorithmic bias. Now, AI algorithms train on biased data, right, which can perpetuate the discrimination and unfair outcomes. But definitely is there. That how this model can give the accuracy, right? That is very important term. Accurate information. Accountability and transparency is also crucial into that. Now, let's take an example of something that how it works, right? So, see, here data is already there, sensors are already there. So through API, it can get the data right here, right? So once you get the data here, several other techniques you can apply, and applicate this data has to be sent to the application. So here you can use ML, forecasting, pattern recognitions, all the things. So the thing is that you can use in this way, like AI controlled drones or robots. Through API sensors I get the data and different issue you can solve. So let's take an example of the fault management architecture, right? This one overview, fault management architecture. So fault detection, you have to detect the fault in particular smart factory or something, right? And you have to identify the defective, where the defect is at, and what is the condition of the defective of the particular systems. Okay, so easily you can use the AI/ML algorithm to send the alerts or send the measurement, particularly run the model on the fault detection service AI algorithm and immediately send the receipt. So predict it properly, right? Perform the prediction and receive the prediction. This way, right here you can already do this AI algorithms. It can self-learning model you can build, right? Self-learning model you can build that immediately run the fault detection and it can enhance the performance, right? Similarly, the video pattern detection also is there. So whatever that, how visually, right, the context visually environment and their context, how you can detect it. Like image classification, either you can use the camera sensors, right, to store the data, apply the model, all the things. Or you can do the language-based predictions, LLM, you can apply here on textual data, right? There are several applications. I just present the 3 or 4 use case here, right? One of the application is image classification augmentation. So some few applications, few use cases I have explained here, and you can see the future of AI-powered IoT. You can enhance the security, personalized experience, increase automation, and system solutions. So several. My main, I would suggest that focus on see, we can integrate the AI into IoT, not an issue, right? We can easily integrate. But how accurate the result is, right? That is my issue. Right. AI can help in predictive maintenance and all the things. Right. But we have to work on the accuracy also, and we have to achieve the higher accuracy so we can predict that yes, higher accuracy is there, so it's correct. Our results are correct. Right. So that's end from my side. Any questions from your side? This is my contact details. You can contact me, right, on email ID and phone number. Any questions?
Hello,
From
sir.
audience? Yes.
No questions, sir.
No questions. Okay. Any question from audience? No questions from your side?
No questions, sir.
Okay. Fine then. Okay, sir.
Yeah, Banu sir is coming. Yes, sir.
Okay. If you have any questions, you can write me on this email ID. I will put in the chat box. How to integrate AI into IoT. Okay. Definitely, I will able to answer all the questions to you and how AI can help because mine I am working in industry, so how AI can help, that is in the industry perspective, that is very important part. So I can guide you, right, how to work on that part. So please email me, reach out to me, or my LinkedIn page is also there. You can search Vishal Rathod, Dr. Vishal Rathod. You can go. Okay, so if you don't have any questions right now, so let's wind up this. Bana sir?
Yeah.
Yeah.
Okay. Thank you very much. Okay.
Sorry for some echo in the audio systems.
No issue, but I think participants are listening. And it was not so bad. Means actually when the voice was coming, little bit humming sound was behind. That's okay. We
Don't worry,
can
the system.
we could have understood it.
Yeah, fine. You can contact me, sir, if any participant has a doubt. I just put my email ID in the chat box.
Yes.
So you
Okay.
can contact me.
If any doubt is there, we'll get back to you through email.
Yeah, sure.
And thanks a lot for sharing the IoT concepts and how we can use AI or how we can combine actually the AI
Yes,
concepts
that would
and
be good.
IoT. Yeah.
I'm definitely telling that integration of AI into IoT because now industry also, government also moving into the AIoT part.
Yes.
Right. So it will definitely help industry and then government. Both.
Yeah, and so
Many
also
projects
you
are-
have thrown the light on the applications as well. Very good.
Yes.
So I think that gave the better idea how exactly these two technologies can be can be run together.
Yes.
Okay. So Manoj sir,
Yes, sir.
I think
I will stop the recording.
You stop the recording and then start. Then I will introduce the second speaker. I think just a minute.
Okay.
You stop the recording, no issue.
Yeah.
So shall I leave, sir?
Yeah, you you can leave, sir.